Yeah, good afternoon all. Before I start, can anyone please confirm whether my voice is clear? Yes. Yes. Okay. How exactly the data storage and processing happening, right? So in Hadoop, the files are divided into blocks. Files are divided into blocks. If the number of blocks if the number of blocks equal to number of slaves, assume that 3 blocks, 3 slaves, 3 systems, B1, B2, and B3. 3 blocks S1, S2, and S3. 3 blocks, 3 system, 3 slaves. F1.txt, think that you got 192 MB. The size is 192 MB. Default block size, assume that default block size 64 MB. Into how many blocks, number of blocks? Into how many blocks? 192 by 64. 3 blocks. 3 blocks, right? Yes. B1, B2, and B3. Assume that you have got some 30 lakh records in this, 10 lakh in this, 10 lakh in this, 10 lakhs in this. See how these blocks, file divided into blocks, and how the blocks are going to be stored across the cluster. Single master, multiple slaves. For this is S1, S2, and S3. What like S1, S2, and S3. S1, S2, and S3. So B1 block here, B2 block here, B3 block here. B1 10 lakh records, B2 10 lakh records, B3 10 lakh. This is master node. Within the master node, we see like name node. Name node, right? This name node stores this file f1.txt. f1.txt stored across f1.txt. B1, B2, B3. B1, B2, and B3. B1 stored in S1, B2 stored in S2, B3 stored in S3. B1, B2, and B3. B1 stored in slave 1, S2, and S3. How this data storage happening, right? In this way. How to file divided into blocks. Into how many blocks? 3 blocks. 3 blocks are stored across 3 systems and is processed parallelly. Data processing, right? Data processing, nothing but the job is to process the file f1.txt. The job is divided into tasks. Number of tasks. Number of tasks equal to number of unique blocks. Number of unique blocks. How many unique blocks? How many unique blocks? 3 blocks. Number of tasks equal number of unique blocks. So how many tasks? 3 tasks. T1, T2, and T3. T1, T2, and T3. 3 tasks. So job to process f1.txt, f1.txt. Yes. Into T1 task, T2 task, and T3 task. T1 is for executing, right? B1. T2 task for executing, B2. T3 task is for executing, B3. Who should execute this T1 task? Who has to execute? Which system has to execute? Which system has, because B1 block T1 task is for executing B1, as B1 is present in the system 1, system 1 only can execute the T1 task. So T1 task, T2 task, T3 task. T1 task should be assigned to S1 only. T2 task should be assigned to S2 only. Why to S2 only? Because only S2 has got this block B2. Executing this block B2 is nothing but T2 task. B2 is present in system 2. System 2 only can execute. T3 task by S3. Yes. 3 tasks. T1, T2, T3 are executed parallelly. By three slaves. S1, S2, and S3. 3 tasks are executed parallelly by 3 slaves, S1, S2, S3. So none of the task is in the waiting state. All the 3 tasks executed by 3 slaves. No task is in the waiting state. Full high speed. You can see high speed here. Full parallelism you can see. High speed, full parallelism. So this is what data processing, data storage and data processing. Now, observe in this case too, file is divided into blocks. Assume if the blocks are more, then number of slaves, number of systems. 4 blocks you got, only 2 systems you got. B1, B2, B3, and B4, 4 blocks. How many systems? S1 and S2. S1, S2. Data storage you observe, right? F1.txt, assume 230 MB. Default block size 64 MB. Into how many blocks? 230 by 64. 230 by 64. How many blocks? 4 blocks. 4 blocks, right? Yes. B1, B2, B3, B4. 4 blocks. 4 blocks, how it is stored across the, yes, only 2 slaves you got. Assume you got 2 systems. Blocks are more, systems are less. S1, S2. B1 here, B2 here. B3 here, B4 here. So here, name node stores metadata, data about data. Nome node stores the metadata, data about data. Actual data is stored in the slaves. Metadata is stored in the master name node. F1.txt into 4 blocks. B1, B2, B3, and B4. Where B1 in S1, where B2 in S2, B3 in S1, B4 in S2. B1 in S1, B2 in S2, B3 in S, B4 in S2, right? B1, okay. Now data processing. Job to process F1.txt. Job should be divided into tasks, number of tasks. Then only the task can be provided to multiple systems can execute the tasks. How many tasks depends on number of unique blocks. I'm using the word unique blocks. How many unique blocks? 4 blocks, right? 4 unique blocks. Means tasks are 4 tasks. T1, T2, T3, and T4. Job to process f1.txt. Job to process f1.txt into how many tasks? T1, T2, T3, T4. T1 for executing. T1 is for executing B1. T2 is for executing B2. T3 for B3. T4 for B4. Who should execute this T1 task? Who should execute this T1 task? Everyone, try to respond. I want the sessions to be interactive. Who can S1 only can execute? T2 task? S2. T3? T4? S2. If you observe here, S1 is there, S2, two systems. S1 should execute T1 and T3. S2 should execute what? S2 should execute T2 and T4. S2 executing T2 and T4. So when T1 is executing, T3 will be in the waiting state. Here in S2, when T2 is executing, T4 will be in the waiting state. Means here only these 2 tasks are executed parallelly. Remaining 2 tasks are in the waiting state. Once the first task execution completed, then only the other task will be executed. So here less speed you can see because some tasks are in the waiting state. Yeah. Less speed. How the data storage and processing is happening, right? Yes. Observe the next case, right? Observe this next case. More blocks. Only one slave. More blocks, but only one slave. More blocks means assume you got 4 blocks. Only one slave. B1, B2, B3, B4. 4 blocks. Only one slave S1. Only one slave S1, right? You got f1.txt. Assume you got divided into 4 blocks, B1, B2, B3, and B4. How these 4 blocks are stored in the single slave, one master and slave. Okay. See, if you got only one slave, right? There is no parallel processing at all. There is no parallel processing at all. So, if you are maintaining more systems, more speed. For example, a labor example I give. For a building construction, if you have got 10 tasks, you brought 10 laborers. All the 10 laborers are working parallelly on the 10 tasks and completes it. You'll get high speed. But if you got only 5 laborers, each labor should do two tasks. Takes more time, right? First, after completing their first task, they need to complete the second task. If 10 laborers, 10 tasks, each task taking 1 hour, within 1 hour, all the 10 tasks gets completed. But if there are only 5 laborers, first they should complete that first task, then they'll complete the second task. 2 hours it takes. But there is, if only one labor executing all the 10 tasks one by one, 10 hours it takes. Same way here, more number of systems, so more parallel processing you can see. Okay, only one system. Here itself B1, here itself B2, here itself B3, here itself B4. This name node, master node or name node. F1.txt. F1.txt divided into B1, B2, B3, B4. B1, B2, B3, B4. Yes. B1 stored by S1 only, B2 also by S1, B3 also by S1, B4 also by S1. B1 by S1, B2 by S1, B3, everyone by S1 only. Yes. Okay. But here four blocks means four tasks. Four tasks means T1, T2, T3, T4. T1, T2, T3, T4. All these four tasks are executed by the single slave S1 sequentially. So no parallel processing here. No parallel processing. Takes lot of time. Yes, takes lot of time, right? Yes. More systems, more speed. Less systems, less speed. If only one system, no parallel processing, right? If you go back to this, if you go back to this case one, T1, T2, T3 are executing parallelly. Suddenly, if any one system goes down, three tasks are executed by the three systems, suddenly this system goes down. Then this 10 lakh records are lost. If the records are sensitive data like banking data, there is a huge loss. Two things you can observe: data is lost and this T2 task is failed. Data is lost and the T2 task is failed. Both you can observe, right? Yes. Yes. How we can able to overcome this kind of situation means we have what replication and fault tolerance mechanism in Hadoop. Replication and fault tolerance. Replication and fault tolerance. Default number of replications. Replications nothing but duplications. Replications nothing but duplications. Default number of replications. Default number of replications, replicas are 3. In Hadoop, default number of replications or replicas are 3 always. You got f1.txt, f1.txt, right? The size. f1.txt. f1.txt, the file size f1.txt, right? You have got a file. The size of that file is like 192 MB. Number of blocks. Default block size 64 MB. Into number of blocks. Number of blocks equal to 192 by 64. How many? 3 blocks. 1 second, just 1 second. Yeah, sorry. Default number of replications are 3. So your file, you got 3 blocks. 3 blocks means B1, B2, B3. B1, B2, B3. B1 replicated by 3 times, B2 replicated by 3 times, B3 replicated by 3 times. Totally 9 blocks you get. How these 9 blocks are stored across 3 systems? You got 3 systems, 1, 2, 3. How these 9 blocks are going to stored across this X? B1, B2, B3, B3, B1, B2. Here B2, B3, B1. So 9 blocks stored across these 3 slaves, right? 9 blocks stored across these 3 slaves. Yes, this is name node. F1.txt divided into F1.txt B1, B2, B3. B1 stored across S1, S2, S3. B2 stored across B1 stored across S1, S2, S3. B2 stored across S1, S2, S3. B3 also stored in S1, S2, and S3. Job to process F1.txt. Job to process F1.txt, right? Number of tasks. Number of tasks equal to number of unique blocks. Number of unique blocks here. Why I am saying the word unique? 9 blocks are 3 blocks. 3 blocks, right? Here 3 blocks, not 9 blocks. 9 blocks are the duplicated blocks. T1, T2, T3. Job to process F1.txt. Job to process F1.txt, right? Yes. T1 task, T2 task, T3 task. T1 is for executing B1, T2 for executing B2, T3 for executing B3. For executing B1, B2, and B3. Who should execute this T1 task here? S1 can execute, S2 can execute, S3 can execute because B1 block is present in S1, S2, and S3. Okay, T2 task by S1, S2, and S3. T3 task also by S1, S2, and S3. These are T1 task can be executed by all. But master node has selected S1 only for executing T1, and the master node has selected executing T2 by S2 only, T3 by S3 only. T3 task to be executed by S3 only. Yes. While executing this T1 task by S1, T2 task by S2, T3 task by, suddenly if this S2 is down, is there any data loss here? Is there any data loss here? No. No data loss, right? Yes. No data loss because still even if S2 is down, still the blocks are available in S1 and S3. S1 and S3. And the T2 task will be assigned to either this S1 or S3. This T2 task will be assigned to S1 or to S3, right? Yes. Yes. Okay. Here, you need to understand, you need to understand two things. T2 task should be assigned to S1 or S3. What is the criteria followed? What is the criteria followed in assigning a task to the slave? Here, T1 task is assigned to S1 only. Why not S2, S3? Why not S2 or S3? Here, T2 task assigned to S2 only. Why not to S1 or S3? Okay. Replication and fault tolerance. Replication means duplication. Default number of replications 3. We can also configure increase or decrease the replications. Okay. Yes. What is the criteria followed in assigning a task to the slave? S1 to T1, S2 to T2, S2 to T3. Suddenly S2 is down. The T2 task to assign to S1 or S3, what is the criteria means? 4 steps criteria. Master node selects the slave which is highly configured. Master node selects the slave which is highly configured, which has high hardware configuration among S1 or S3. If both are equally configured, both have the same high configuration, then master node selects the slave which is more ideal, more free among S1 and S3. If both the slaves are free, master node selects the slave which is nearest to it. If both the slaves are free, if the both the slaves are free, then master node selects the slave which is nearest to it. Yes. If both are equally near means, see, master can be in one country, slave can be in different countries. Master in one state and slaves are in different states. Okay. Master node can be in one city, all the slaves in different cities. If name node is down, right, we have got secondary name node available, but from Hadoop 2 version onwards, we have got multiple name nodes available. If master node is okay, if if both the slaves are equally near, then master node selects the slave which has good health status. Health status means among both the slaves, one slave like a hardware and software config. If both have good health status, that is software and hardware health status, right? Then master node selects any one slave randomly. Yes, this is the four steps criteria, right? If in assigning a task to the slave, in assigning a task to the slave.
Uh,
What is it?
question. So why T1 assigned by S1 only? This master decided because both all the blocks are available across the three nodes, right? So why T1 assigned to S1 only? Why T2 assigned to S3? Sorry, T2 assigned to S2 and
Yes,
T3
yes.
assigned to S3.
Why, yes, why the task is assigned? Here your query is T1 can be executed by S1, S2, S3.
Mm-hmm.
But for executing T1, S1 is selected. For executing T2, S2 is selected. Why S1 only? Why not S2 and S3? That's what among S1, S2, and S3, which has to be selected means the one which has got highly configured, which has high hardware configuration. The one that is has got high config that will be selected. Okay, assume the master node selects this. Okay, for example, okay, next master node, if all of them have got same highly configured, all of them have got high hardware configuration, right? Then the one which is more free will be selected. The one which is more free. Think all are free, then it selects which is nearest to it. If all are equally near, then which has got a good health status. Still, all these four are satisfied, it selects any one slave randomly.
So there could be a probability that there could be a probability that it could be T2, T1 and T3 also, or T3, T2 or T1 also, right? I mean, all the four conditions would be if all the four conditions would be satisfied, then it could be select randomly, right? So S1 could assign to S2, T2 and S2 could assign to T3 like that randomly.
So the three tasks. So first, what is the criteria followed is these four steps.
Right, right, right.
Four steps criteria is followed. So if mostly in the second step, right? Second step, which is more free among these three, the second step will allocate it, which is more free. For example, a system one executing two tasks, S2 executing one task, S3 executing four tasks. Which one is more free means S1 has got only one task, so it will be assigned to S2. Right. Fault tolerance. What do you mean by fault tolerance means if multiple tasks are executed by multiple slaves S1, S2, S3, if suddenly if any one slave goes down, if any one slave goes down, then the task T2, then the task T2 will be assigned to the available slaves. This process is called as fault tolerance. When multiple tasks executed by multiple slaves, if any one slave goes down, then the task of that slave will be assigned to the other slaves. This process is called fault tolerance. Okay. We can also configure the replication. We can also configure the replication. I said we can configure block size. We can have our own block size. We can also configure replication. We can also configure replication, right? Okay. So here the same, go to that Hadoop install folder, hdfs-site.xml, open that file, property, opening and closing, name dfs.replication. By default, it takes 3. If you want to increase 4 or 5, you can increase here. Block size also, want like 50 MB or 100 MB, or by default it is 64. The latest version 128 MB, right? But so here I have a query here, right? Yes. Okay, before that, design principles with respect to replication. Replication applicable only for data, but not for metadata. Replication only for data, right? Not for metadata. The master node metadata is stored. In the master node, metadata is stored, right? Yes. Yes. Okay. Replication is applicable only within the slave nodes. Replication is applicable within only the slave nodes, but not within the master node. But not within the master node. All the same replicas cannot be within the same slave. Means all the same replicas means in S1 storing all B1s, in S2 storing all B2s, in S3 all storing B3s. If S2 is down, assume if S2 is down. Hmm. If S2 is down, all the B2 blocks are lost, right? So all the same replicas cannot be within the same slave. All the same replicas cannot be within the same slave, right? Because if any one system goes down, then that block is lost. Maximum number of replications equal to number of slaves. Maximum number of replications equal to number of slaves. Maximum number of replications equal to number of slaves. If you have got 4 slaves, maximum 4 replications you can keep. If you have got 5 slaves, 5 replications you can keep. So block size, if I talk about the default block size, which is advantageous, having bigger blocks, default block size, or smaller block size. Try to understand. You can increase the block size by default. Okay. Default block size. We can configure default block size. By default, it is 128 MB in the latest. In the latest versions, it takes 128 MB. Setting the default block size. If replication not available for, yes, replications means duplications. Replications means duplications. Default replications, this is all for master, this is for data nodes. Yes, the data is duplicated, but in the master node, you won't store data, right? In the master node, there won't be any data, right? Only data will be within the slave nodes. Your entire data is stored by the slaves. If this is your data, data is stored by the slaves. Means the data is replicated by 3 times or multiple times. 3 times duplicated or 4 times duplicated, right? Your data always stored in the slaves, not in the master. That's why replications to the data in the data nodes. So default block size, we can also configure our own block size, right? We can also configure our own block size, which is advantageous, bigger block size or smaller block size. I want sessions to be interactive, right? Everyone try to respond. Yes. Which is advantageous, having a bigger default block size or smaller block size?
Smaller, I think.
Okay. We'll take one example on the bigger. We'll take one example on smaller. Just compare it. Which one is advantageous? Example one. A file f1.txt 900 MB is there. 900 MB is there. The file size is 900 MB. I'm configuring the default block size as 500 MB. If smaller, we choose it, it will have more number of tasks. Default block size 500 MB. You are keeping the block size as 500 MB. Default block size, it's the thing that you kept 500 MB. Is it advantageous? Into how many blocks this file will be divided? 2 blocks. Your file is divided into 2 blocks, B1, B2. Assume you have got 40 node cluster. Assume you have got 40 node cluster where you are using only 2 slaves. You have got 40 node cluster where you are using only 2 slaves. Less speed, right? For example, for building construction, you got some 30 labors, but you are using only 2 labors to work. If you assign the same work into 30 labors, more speed you can achieve here also. Even though you have got 40 systems, but you are using only 2 systems. 2 systems are running parallelly. To want to have much parallelism, to increase the parallel processing, if you have got more number of systems are working, running parallelly, more speed. Instead of, if the default block size is 64 MB, nearly 15 slaves will be running parallelly, more speed you will be getting. Example 2, you see f1.txt 50 MB, a very small file. You take a very small file. Default block size 5 MB. Default block size 5 MB. You have kept the default block size to 5 MB, very small block size. Means this stored across 10 systems processed parallelly. Means this 50 MB file it's divided into 5 MB, means totally 10 blocks stored across 10 systems. Means here a small file, already 50 MB is a very small file. Already it's divided into 10 smaller parts. And again computed, and the output is collected, and it's time taking process, right? Dividing and storing, processing, again collecting the output for a very small file is a time taking process. So the block size should not be too small, the block size should not be too large. So the block size should not too big or too small. So the latest version, the default block size is 128 MB. The default block size is 128 MB, right? Yes. This Hadoop architecture. Storage architectural components and processing architectural components. In Hadoop, storage architectural components, we have what? Processing architectural components. Storage architectural components, name node, data node, and secondary name node. Processing architectural components, job tracker and task tracker. Processing architectural, job tracker, and task tracker. See, observe this storage architectural components. First one, name node. If we talk master node, these are the slave nodes. Slave 1 means data node 1, slave 2, data node 2, slave 3, data node 3. See, if you talk about the name node, number of blocks equal to number of slaves. 4 blocks, 4 systems. Think that f1.txt, f1.txt, f1.txt size 240 MB, default block size 64 MB. Into how many blocks? Into how many blocks? This f1 is divided means 240 by 64, 4 blocks, B1, B2, B3, B4. Observe this B1, B2, B3, B4. B1 is stored in S1, B2 is stored in S2, B3 in S3, B4 in S4. So clearly understand in which slave, in which block stored in which slaves, memory address locations. This B1 is stored in S1 at so and so memory location address. This B2 is stored in S2, B2 is stored in S2 at so and so memory location address. B3 is stored in S3 in so and so memory location. B4 is stored in S4 and so memory location address. So these blocks are stored in the slaves only, okay? But name node should maintain which blocks stored in which slaves and which is the memory address. Tomorrow, if you want to retrieve, you need to know that memory location address, the blocks, the slaves information. Who maintains all this? Master node maintains it. That is name node maintains. Name node is present. See, all these are the system services. Name node, data node, and secondary node are the system services. Processing architecture like job tracker and task tracker also are the system services. Now try to say me what are the tasks, what are the tasks of the name node? Name node responsibilities. If you want to retrieve f1.txt file into which has got 4 blocks, retrieving f1.txt, b1, b2, b3, b4, name node to access the memory locations, name node to access the memory locations, to access the b1, b2, b3, b4. b1 is stored in which memory location, b2 memory location, b3, b4. I need to combine all these memory locations to access these blocks. Name node responsibilities. Now from this understanding, name node responsibilities are what? to store the physical memory locations of the blocks of a file. To store the physical memory locations of the blocks of a file. To combine physical memory locations of the blocks so that the file can be formulated. To combine the physical memory locations of the blocks so that the file can be formulated. So that the file can be formulated, right? So here, to combine the physical memory locations of the blocks so that the file can be formulated. To store the physical memory locations, right? To store the physical memory locations. Yes. To store the physical memory locations of the blocks of a file, physical memory locations of the blocks of a file. To combine, if you want to retrieve the file, for combining that memory locations of the block so that it can be, and for storing the name node stores the metadata information. Data about data. It won't store data, it stores metadata, data about data. That is name node responsibilities. Data node responsibilities. Only one responsibility, storing the data, storing the HDFS blocks. Storing the HDFS blocks of a file. The number of data nodes required depends upon the volume of the incoming data. The number of data nodes required depends upon the volume of incoming data. And here, in the failure of, just like in the absence of the principal, we have got vice principal, right? In the same way, in the absence of the name node, if the name node fails, we have got secondary name node available. We have got secondary name node. We have got secondary name node, yes. Secondary name node similar to name node, yes. If name node is down, then the entire cluster will be down. So if the name node is down, then immediately we have secondary name node. Then immediately we have got secondary name node. Secondary name node responsibility same as name node to store the physical memory locations of the blocks, combining the physical memory locations, storing the metadata information. Right. But secondary name node is not 100% backup node for name node. Secondary name node is not 100% backup node for name node. Because if name node can read, write, and update. But whereas secondary name node can only read. Whereas secondary name node can only read, right? Yes. See, name node can read, write, and update. See, metadata, where name node stores metadata information means in two files. Name node stores all the metadata information in two files, fs, image, and edits. Remember, where name node stores that metadata. See, all the systems, how communication happens between name node and a data node. Observe here, name node and data node. See that how name node comes to know that a data node is down. How name node comes to know that data node is down. A particular, okay, how a name node, how it comes to know the particular slave is down means there is some heartbeat signals between the name node and data node. Data node sends heartbeat signals to name node for every 2 seconds. Data node sends heartbeat signals to name node for every 2 seconds. If that heartbeat signals are missing, right, then name node thinks the data node is down.
Sir, I have a question.
Yes.
I just wanted to know, there would be like number of slaves, right? Data nodes. So the data also will be stored in the actual data in the data nodes.
See, 1 second.
Just
Slaves are there. Slaves means systems, CPUs.
mhm.
Slaves means nodes, means systems. Within the each system, right? System 1 means data node 1. System 2 means data node 2. System 3, data node 3. 10 systems, 10 data nodes. Data node is a system service, is a logical component.
Yeah, I got it. But the thing here is the data nodes will have the hard disk, right? Data. That's where the data will be stored.
Hmm.
So now the question here is, how
Hmm.
the real time, how the system configures in the real time. Is it cool or like the hard disk will be terabyte, petabyte kind of thing, or it would be so because the blocks will be keep on storing based on that. If hard disk will be full, right, then the slave nodes performance also
See,
decreases, right?
see here, 2 TB file is there. How the 2 TB file will be stored, right? 2 TB divided into some 20 parts. 20 parts are stored across 20 systems.
Right.
20 systems means storage is sufficient, right? 2 TB file storing across 20 systems is divided into 20 parts stored across 20 systems and are executed parallelly. And if you've got 4 TB file also divided into smaller parts stored across multiple systems.
Got it, sir. But it's a repetitive process, right? The 2 TB keeps on coming.
No, if any new file comes, right, it will divide it into blocks and stores across the systems. Any other new file comes, it divides into blocks and stores. Why? Because a single system cannot accommodate it. So in this way, still, if if a bigger data files are coming, we'll keep on increasing our cluster capacity.
Got
Okay,
it.
fine. Name node, see, secondary name node is not 100% backup node for name node because it can only read, it cannot perform write or update, but name node can read, write or update, right? Fine, fine. So, okay, about this processing architecture, right? Processing architecture, about those things I'll be discussing in the next session. And tomorrow, just I'll be briefing you before I go with HDFS commands, right? I'll be just briefing you about with the Linux commands. Basic the Linux commands required for understanding the HDFS, right? So I'll just discuss that processing architecture followed by that commands, right? So just check your mails, right? Once again, you will be getting a new link for tomorrow's session, right? By today evening, you will be getting a new link. Still, if anyone has not got enrolled, right? Try to get enrolled for it. A new link and the same link you can follow up to the end of the course, right? You can say by evening, you will be getting a new link for tomorrow's session. Tomorrow, we will have the session at 2 o'clock. Okay, fine. So I'll stop for now. Well, forward you these notes, right? You'll be getting these notes through mail.